We're diving into a late fee calculator that will introduce you to Elixir's date, time, and naive DateTime modules. Get ready to discover the power and simplicity of Elixir's date and time functions. I'm Kevin, and in these videos I explore AI tools to help us learn. I start with getting Copilot to add documentation and provide a starting solution. We'll evaluate Copilot's code and explore alternate approaches. I'll include segments of NotebookLM explainer videos or quizzes to introduce concepts. Let's see how NotebookLM introduces library fees now.
Are you still fumbling around with string manipulation and weird timestamps? The idiomatic Elixir way is to lean into its awesome built-in tools for handling dates and times. Nailing this is no joke, a huge level up for your code.
And lucky for us, Elixir hands us the perfect toolkit for the job. You've got your date module for just calendar dates, time for the time of day, and the real star of our show today, naive DateTime. This little guy is our secret weapon for when we need both date and time, but don't need to worry about time zones.
Think about it. A naive DateTime is perfect for what we're doing here. A local library, probably in a single time zone. It gives us all the power of a full date and time struct, but we get to sidestep all the complexity of time zone management. It's clean, it's simple, and it's exactly what we need.
All right, as I mentioned in the opening, I've already had Copilot document the starting solution with function documents, function specs, a module document, and provide an initial solution. I want to spend more time critiquing and evaluating various approaches and less time having you watch me type. So, for date time from string, this looks pretty perfect. Native date time from ISO 8601, bang, with the string. So when I looked at this, I was like, well, that works perfectly well. You could have also said, well, what if the string that was passed in wasn't or had extra white spaces or something? You might be compelled to trim it first. This particular exercise doesn't require that. So I don't think we need to include it in our solution. Another catch point might have been the bang versus not bang. So there is another version of this function from 8601 without the bang. And what this would return to you is a tagged tuple. So what that would say is I'm going to get back either OK and the date time value, or I'm going to get an error and some sort of reason. And then you typically wouldn't do that. There's no point in doing this inside this function because it's either going to return the value or throw an error, which is exactly what the bang version does. You would do this if the caller was expected to handle the error. So there's no need in doing any of this either. So the out-of-the-box solution that Copilot provided is perfect for date time from string. We'll go with that.
Now that we have a proper struct, we can actually talk to it. We can ask it smart questions. We're not just dealing with text anymore, we're dealing with the concept of time. And that unlocks our ability to start applying the library's rules.
All right, let's take a look at before noon. So it's supposed to return true if the time portion of the naive date time provided is before noon. Copilot chose to declare a local variable for the noon value, and then it said, let's take the date time, we'll convert it to a time, and then we'll do time compare noon to that time component and see if it's less than. This is a pretty good solution. A first tweak I would make is either to suggest that noon should be a module constant, like so, and then used as that module constant here. Or I think that this syntax reads pretty clearly, so I would be inclined to just put it straight in line like that. There's another approach that once you have this date time as a struct, you can just refer to the hour and say is less than 12. And I think this is marginally more efficient from a processing perspective, but it's less semantically correct. I think given that you're working with dates and times, you should stick with the date and time modules so that it's clear where we're doing a time compare. But I'm really hard pressed to say why the other is terribly wrong. There's also a before function. So we could have written this as take the date time, convert it to a time, and then asked, is it before noon? So rather than saying, let's do the compare and then check the result of compare, which is either going to be less than, equal to, or greater than, to less than. I think this is the best answer from a ongoing code perspective. The reason I'm going to stick with this version is that the hints file specifically mentioned time compare. So they're really trying to introduce you to this time compare function and show that it's there. Also, this before function is much more recent. So it could have been also the instructions were written before that was available. So we'll stick with the equals less than atom, but I really think this last version would be the version I would want to see in production.
So, on to the next puzzle. The library has this rule, right? The return period actually depends on that before noon thing we just figured out. It's a classic conditional logic problem, but with Elixir's date tools, it's an absolute breeze. And this is where it all starts to click together. That input time, it's afternoon. So our before noon function we just wrote would say false. That tells our code to add 29 days, and Elixir's date.add function handles all the tricky stuff, like crossing over months or years. All we get back is a nice, clean date struct.
Return date is supposed to add a number of days to the checkout date and calculate when the book needs to be back. So you're given a checkout date time, and you ask with our previous function, if it's before noon, we'll do 28 days. Otherwise, we choose 29 days so that the person taking out the book gets a full 28 days. That's more or less fine. I don't see the need to change that much of any. You could decide to make a private function that did that for you, but it's one-liner, it's inline, it's fine. Checkout date time, we take that, we pipe it into add this many days. Wait, what? That's a lot of days? What's going on here? Well, add by default takes a number of seconds to add. So this is taking those days and multiplying it out by how many days are in a second, or how many seconds are in a day. So really, if we wanted to clarify this, we should say that seconds in a day is a module constant. Now it's a little clearer that we're saying let's add days times seconds in a day. So you kind of can work out fairly quickly that we're adding a number of seconds. So this is better. And the instructions specifically mention the seconds in a day, which is why I think that that Copilot provided the solution this way. There is another version of add where instead of dealing with seconds, you just specify that the unit that we're adding is a day unit. So then we don't even need this whole seconds in a day module constant. We don't need to multiply it. We simply take the number of days we calculated and we add it to the date time. This function is also supposed to just return the date. So both of these say after you calculate out how many days, just convert it to a date. So this is the same. No problems there. In newer versions, there is yet another function called, well, let me do it this way around. Shift. And Shift has even more choices for what the allowed units are. There's also a subtle difference about add doing Gregorian calendar things and Shift doing other but it's well beyond the scope of this. So you could have also said, well, shift looks like a more semantically correct function to call. In terms of this exercise, since the exercise itself mentions the seconds in the day, I'm going to say that our improved, let's make a module constant and then do the multiplication. I'm going to say that that's the answer we should go with. I think that add or now shift with how many days is probably the better answer in production. But for this exercise, I think this is the intended result.
So we know when the book should have been returned. But to figure out a late fee, we got to compare that to when it actually got back. This tees us up perfectly for the next critical calculation. Okay, and this is a classic trap. I've seen so many people fall into this. You might just want to throw a greater than or less than sign at it, but nope, that's a mistake. We're comparing two totally different kinds of structs here, a date and a native date time, and we need to be smart about it.
Days late. Okay, it's right, I guess, but it's very non-idiomatic Elixir and rather hard to read as far as I'm concerned. Pipes would make this a whole lot better. So for example, here we're taking the actual return date time, we're converting it to a date, and we're storing it, and then we're turning around and using it. Here, we could just pipe it. Then we do this almost the same with diff, where we store it only just to reuse it, but then we don't care about diff anymore after that. So you could write it this way, where we take the actual return date time, we convert it to a date, that's this line. We pipe that into diff, that's this line. And then we take the maximum of what that is in 0, which is the same as this line. So I find this block here reads a whole lot better than this block here. And they're functionally equivalent. So I think we should go with the piped solution. Did you know the widely used DateTime module leverages a critical dependency called tz-data? tz-data provides the latest time zone definitions and rules from around the world. So when dealing with actual global times in your Elixir applications, you're not just getting a simple offset, you're getting a constantly updated, robust understanding of historical and future time zone shifts, ensuring your library's due dates are accurate whether the book is checked out in London or Tokyo. Monday is pretty good. Copilot's effort is pretty good. This is unfortunate, but we could improve this slightly by declaring a module constant so that at least we can now say if the day of the week is Monday. I think that reads a little bit better. We've got a mix of a function call and a pipe, so we probably could improve this a little bit by making the whole thing a pipeline. I think I'd go with that. Is there a step I didn't fully explain or an angle I didn't consider? Your feedback makes a difference. Leave a comment below. Calculate late fees is a little bit of a train wreck. Not entirely Copilot's fault. We'll get into that in a minute. But let's see if we can sort out what we have here. We have the checkout date. So the first two lines, they're similar in that they're trying to get the date times from the strings. Can appreciate that. Checkout date is then reused in line 3, and it's not affiliated there. So let's first put the return date up on its own line, and then take a look at these two lines to get the planned return. We don't actually use checkout date any place but to get the planned return, so there's kind of no point in storing it as a local variable. So let's put these things into one line. So let's take the checkout and pipe that to getting the date time, and then pipe that into the return date and getting rid of that line. All right. So now we have our return date and our planned return date. Let's see what we're doing next. All right, the next two lines are trying to calculate the late fee. And in order to get the late fee, we need the days late. And that's the only reason we're storing days late. And I think the function name itself communicates well enough what the intent is that we can just say, get the days late and multiply by the rate. I don't think there's a need to have a local variable. It doesn't add any clarity, in my opinion. And then finally, we say if it's Monday, then we're going to do this division. Otherwise, we're going to return the fee. I think this is about as good as we can do for the exercise and the constraints of the exercise. I think the number, well, there's two things I think we could possibly further improve. One is we could improve the clarity of this if Monday statement by putting it in a function, which would be something like apply discount. And then it would be clearer that that's what this code is doing. But I think the bigger thing is that calculate late fee takes strings for the date times, which forces us to do this conversion, which muddies up the core of what we're trying to do, which is to calculate the late fee. And I find this a little bit odd because every other function, aside from DateTime from string, takes the date time. So, from an API perspective, either all of these should take the string and expect the conversion to be done internally, or they should all take naive date times so that you can just get to the business at hand. You see, takes a naive date time. Return date takes a naive date time. So if this last one were to also take naive date times, then these two things would be much simpler, and we could get straight to the calling days late. So if we had the power to change the API, you could provide another version of this that took the date times. The version that takes strings could just calculate the date times and then make a recursive call. Okay. But we're not allowed to do that for these, or encouraged to do that. You will actually get barked at if you change this fee by the exorcism reviewing tool. So I think that I will leave my solution like this. It's time you click the like and subscribe buttons to keep your Elixir learning on schedule. Dive into the playlist to build your Elixir expertise one powerful function at a time. See you there.